2.2 is just an extension of arithmetic and geometric sequences. Now this first page looks awful, I know, but I'll get into it. As a reminder, arithmetic sequences behave like what type of functions? See if I remember. Linear, yes. And geometric sequences behave like exponential. And when we're graphing like sequences, we just do points. We don't connect the lines. So this would be linear. And then exponential would be like something like that. So it starts out slow and then it goes whoosh. The big thing that College Board wants to point out is that when you look at the formula for an arithmetic sequence and you look at a formula for a linear function, they're very, very similar. So an arithmetic sequence, this is the one where we use the zero term. It's basically y equals mx plus b. So your zero term is your y-intercept. Your common difference is like your slope. And your n is your x value. And the same thing if I use this other form, like this, it's the same thing as point slope form, which you probably haven't actually even seen before. But that's another way to write an equation of a line. Geometric, you're not actually even introduced to exponential functions, so it's hard for you to be like, oh yeah, those look the same. But a geometric sequence is like g0 times r to the n, whereas exponential is like a times b to the x. They're basically just the same type of function. Arithmetic sequences are linear functions. Geometric are exponential. And here's just kind of saying the same thing again. When you are looking at linear functions, if you look at like a t-table, you look at the arithmetic sequences, your y values go up by the same amount. It's like plus 2, plus 2, plus 2. The exponential, we say that they change proportionally, which means they multiply by the same thing. They're times 2, times 2, times 2. So linear is addition, exponential is multiplication. It's important things to remember. So for each table, determine if the function could be linear, exponential, or neither. So we're going to look to see if we're multiplying by the same thing, are we adding the same thing, or is it neither? So what's happening on number 1? Multiplying by 2. Are my x values going up by the same amount? Yes. Yeah, so that's necessary. So times 2, times 2, times 2, times 2. So this means that it is exponential. Because, and I'm just going to restate, because the output values change proportionally. Exponential, because the output values change proportionally. I can imagine a multiple choice question that would have this, and your multiple choice might be exponential because the output values change proportionally. You might have another one that says exponential because the output values change at a constant rate. You saw similar questions like that early on this year in the first unit. So not only do you have to know that it's exponential, you need to remember exponential proportional. Exponential proportional. Linear, constant. Kind of get those words together. So number 2, what's happening? Subtracting 2. So it's minus 2, minus 2. Check all the way down. So I would say that it is what? Linear. Because the output values change at a constant rate. So here we have a graph. Let's complete the table. Our n, that is our term number, which are also our x values. So I don't have a 0 term. Like I don't have a point on there. I could figure it out. Let's go ahead and fill in the ones I do have right off. For example, my second term is -3. My third term is -1. What's my fourth term? 1. Fifth term?
3.
And sixth term? 5. So what's my 0 term? What would it have to be?
-7.
-7. Good. So what is my common difference? 2. And my formula, AN equals A0 plus DN. So -7 plus 2N. And if this was a line, you would say, okay, well, my y-intercept is -7, my slope, 2/1. So you would say 2x minus 7. Same thing. So, all right, well, what if this was a linear function? How would I write that as a linear function? I just said y equals 2x minus 7. Here we have an arithmetic sequence. It's telling us that it gave us 2 random terms. We need to figure out these missing numbers, and then it's asking for the domain and range. So to find the missing numbers, we need to find the common difference. And remember, that's basically slope. You subtract your y's on top, your x is on bottom. So 17 minus -39 on top, 1 minus 8 on bottom. We get -8.
It doesn't matter what order.
Correct. If you do -39 minus 17, just make sure you do 8 minus 1. If you switch one of the numbers, you got to switch them both. And so now I can fill in the table by just subtracting 8. domain and range. These are individual points. It's just 1, just 2. We're not going to do an interval. I'm not going to do 1, 8. The interval 1, 8 means I'm including 1.1, 1.6, 3.29. If you do an interval, you mean you are including all of the decimals. We're not. When it's just individual points, you literally just have to list them out. 1, 2, 3, 4, 5, 6, 7, 8. And in your range, we like to go smallest to largest. So negative 39, negative 31, negative 23, and keep going. Any questions? All right. A large theater has rows of seats where the number of seats in each row can be modeled by an arithmetic sequence. If the fifth row has 31 seats, right there, I'm going to stop and I'm going to write A5 equals 31. And the 11th row has 49 seats. I'm going to write A11 equals 49. Determine how many seats there are in the 25th row. Well, I first have to know the common difference. That's a huge part of these formulas. 31 minus 49, 5 minus 11 on bottom. This would be negative 18 over negative 6. Which is 3. And we started arithmetic sequences today in Algebra 2, so that's why those are up there. So remember, this is your generic formula. A1 plus D n minus 1. That's just the common one you first learned. But what we figured out, or what I figured out, is that you can replace those ones with anything you want. So I could replace them with a 5. That would be smart of me to do because I have a 5. So I can say AN equals A5 plus D n minus 5. Just make sure if you use A5, you put a 5 over here as well. If you wanted to use A11, you could just put an 11 over here. And so I'm finding A25. So 31 plus 3 times 25 minus 5. Let's see, this would be 20 times 3 is 60. 31 and 60 is 91 seats. Any questions? Right. Number 6, we have a geometric sequence. Notice this is exponential. This one is what we call exponential decay because it's going down. So first term, second term, third term. Well, it's kind of somewhere in between 10 and 20. We don't want to get an approximation. We know geometric multiplies by the same thing every time. which is for dividing. What do I multiply 64 by to get to 32? 1/2. 64 times a half. We're dividing by 2, which is the same as multiplying by half. So 32 times a half is what? 16 times a half? 8. We got 4 times a half, 2, and then 1. And so the common ratio, we can do, I like using the 0 term if possible, times r to the n. What would my 0 term be? 128. So if we go backwards, I would multiply by 2, yep, and get 128. Good. And if I wrote this out like it was just a normal exponential function, I would write y equals 128 times 1/2 to the x. They're essentially the same thing. Any questions? Number 7. This is a geometric sequence. I've given you 2 terms. You could probably guess and check to figure out what your common ratio is. Or, this is the one where you do the root. So, it's going to be a 3 minus 1 root, or a square root. And I'll divide 36 by 144. The square root 36 divided by 144 is 1/2. So my ratio, again, on this one is 1/2. What's 144 times a half? Yep. Then the next one will be 36 times a half, or divided by 2, 18. And then I get 9. Then 9 over 2. Because we don't want, they're not putting decimals, they're putting fractions. What is 9/2 divided by 2? Or 9/2 times a half? It'd be 9 over 4. Because 9 over 2 times 1/2, you multiply straight across. So domain and range, again, it's going to be just a straight list, no intervals. So domain is just the numbers 1 through 7. And then range, 9/4, 9/2, 9, 18, 36, 72, 144. All right, a wild rumor is spreading that Miss Johnson's daughter won first place in the prettiest baby contest. The number of people that have heard the rumor can be modeled using a geometric sequence, where 43 people have heard the rumor on day 3. So this is going to be G3 equals 43. And 140 people have heard the rumor on day 6. So G6 is 140. According to the model, how many people to the nearest whole number, we don't have half of people, have heard the rumor by day 10. I think that's day 10. So we need to know the common ratio. So R, we do a root. It's going to be the 6 minus 3 root, or the cubed root. And then 140 divided by 43. I do get a decimal. So we want to avoid a lot of rounding. So I'm going to put 5 decimal places. But when I go to type it in the type it back in the calculator, instead of typing this out, I'm going to go select this, and it'll bring it down to my calculator. And I'll show you that. So G of n can be found by doing, since I have G3, I'm going to do G3 times R to the n minus 3 power. So 43 times that 1.48213. What's my n?
10.
10, because it's the 10th day is what I'm looking for. 10 minus 3. So I'm going to do 43 times, and I'm going to do parentheses just to be safe. I'm going to highlight that and hit enter, and it brings it down to the 7th power. So how many people are we going to go with? 676 people. Let's see, 43 times, let me just see what happened if you like rounded. So this one, if you rounded it to 3 decimal places, it doesn't make a huge difference, but you would have rounded down to 675. And you would have lost points on that. I mean, I would think on a multiple choice test, there probably would be 675 and 676 on there. Could be wrong, but don't know. Alright, so we have 2 other questions that are just random questions to answer. Sam created a new website and wants to track the number of people that visit it weekly. He estimates an increase by 0.4% each week. That's going to be your ratio. Whenever we see a percentage, it's going to be geometric. Oh, I have some up here. I'm sorry, Autumn. That was my fault. So that's going to be our ratio. At the 4th week, there were 230 people that visited the website. So G of 4 equals 230. Write a function to represent the website traffic. We're not finding a specific time, we're just writing a general function. So G of n equals, which term would make the most sense to use here? What I put here? G what? G4. Yeah, don't put G1. I don't have G1. G4 times r, and then I would have n minus 4 in the exponent. G4 is 230. What's my r? It is not 0.4.
So it's not 4 over 10? 4 over 10.
Nope.
That was
All right. First of all, it's 0.4%. So that would be 0.004. But it's an increase of that amount. So let me think. So first of all, 0.04%. You want to take your, no, I said that wrong. 0.4%. We go 1, 2 to the left. So this equals 0.004 as a decimal. But it's that much increase on what's already there. So you need to put a 1 in front of that. For example, when you go to the store, you have 6% sales tax. When they calculate the sales tax, that's added on to what it already costs. It's not like you go up there and you just pay 6% of the cost. So if you have, let's say you pick out groceries and you're at $38 and you find out what the sales tax is, $228. You're paying $228 on top of the 38. Now, if I take 38 times 1.06, it already adds it back in there for me. So my ratio is not just 0.004. We got to put the 1 so it'll add that traffic onto it. So it's 1.004 to the n minus 4 power. Because it says it's an increase of 0.4% each week. So whatever it started with, the next week is going to be that much plus 0.4%, which is not a lot. 0.4%, 0.004. And if I want to find, oh, that's just my function. So it didn't ask me to find a certain week. Number 10 says to write an equation to match this graph. This is different than what we've done. I'm going to go find points that are right on my line. For example, I have 5, 1, 6, 2, and 7, 4. If I think of this in the sense of sequences, geometric sequences, it is exponential. This would be as if my 5th term is 1. I use G. My 6th term is 2. My 7th term is 4. If that were the case, what is my ratio? 2, because I'm multiplying by 2 to get my y values. So I can say, all right, Gn equals, we can use any of these we want, G5 times r to the n minus 5, which is 1 times 2 to the n minus 5, which is really just 2 to the n minus 5 power.